Alright, so the review for systems of equations. Now, there's a multitude of doing all these problems. It kind of lays out whether we should do it by graphing or substitution and elimination, all that good stuff. So on this version, I'm going to do just the graphing, just the substitution. I'm going to do the quick, easy, whatever fits best. On the extended edition, I'm going to go ahead and do all the different versions and show y'all how to study this stuff properly. Now, on number 1, it says to solve by graphing. So what we're going to do is we're going to look at these equations, okay? Right here, it says that it is going to cross at -2. So we go ahead and we draw a dot right here at -2. And then this right here tells us it's going to go up to right 1. So up to right 1, okay? Now, we're going to go up to 1, 2, over 1. Up 2, over 1. And we're going to do that for the whole graph, okay? And as we can see, this forms a nice line, and we can just go ahead and connect those dots, draw a little arrow on each end, and that part of the problem is done. Now, this part right here tells us that we're going to go and start at -4. So we go ahead and we start right there. And then this part tells us that we're going to go up 3. So 1, 2, 3, over 1. Right there. We're going to go 1, 2, 3, over 1. 1, 2, 3, over 1. Okay? And then, let's see, we can get one more down here at the bottom. So we're going to go ahead and we're going to connect those dots. I don't have a straight edge. I do apologize. My lines aren't going to be perfectly straight. But that's beside the point. Right there. As you can see, we have 2 dots in the same place. Therefore, that is going to be our answer. So, our final answer winds up being 2, 2. Okay? That is where those 2 lines intersect. Now, same thing is going to go for number 2. Okay? As you can see, this one crosses at -5. We go down 5 on the y-axis and put a dot. This part right here tells us that we're going to go up 3 over 1. So we go up 3, right 1. So we go 1, 2, 3, over 1. 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 And we go ahead and we connect those dots. Just like that. Now, we go ahead and do the next one. This part says that we're going to cross at 2. Okay, this part says that we're going to go up 3 over 1. Now, if you notice, that right here looks a heck of a lot like that. Okay? Now, we're going to go ahead and draw our line. We're going to go 1, 2, 3, over 1. 1, 2, 3, over 1. Over 1. 1, 2, 3, over 1. 1, 2, 3, over 1. Now, as you can see, whenever we do this, we wind up with 2 lines that are parallel. They cross at different points on the y-axis, and they have the same slope. Therefore, they are parallel. Okay? When things are parallel in this game, okay, that means that there is no solution. Okay? So, that is the answer to this question. The answer is that there is no answer. It's no solution. Alright? Now, number 3. Okay? Number 3 is very simple, okay? Y equals, okay, goes like that. Okay? X equals is going to look a little something like that. Okay? It's going to go, X equals is going to go up and down. Y equals is going to go left to right. Okay? Now, the y equals -4. Okay? That means that we're going to cross the y-axis at -4, and we're going to draw a line indicating that. Okay? Now, for the x equals 3, that means that we have a vertical line passing through 3, and we go ahead and draw a vertical line just like that. Alright? Now, as you can see, right here, there is a clear indication of a solution. So that solution is going to be 3, negative 4. So we'll go ahead and put that right there. Okay, and we put that in parentheses. Alright, so that's how we do the graphing part of this. It's very simple, should be that easy, alright? Moving on. Okay, this section tells us that we need to solve the following systems by substitution or elimination. What we have to do is we have to actually pick between the substitution or elimination. Now, for substitution, what we're going to look for is we're going to look for y equals blah, or we're going to look for x equals blah. Now, that is just an indicator that, hey, I should probably use substitution for this. Okay, now for elimination, what we're going to look for is we're going to look for the two systems to be lined up. So we're going to have x above x plus y above y, and then we're going to have the equal signs lined up, and then we're going to have a number lined up. Okay, and that's what elimination is going to look like for us, okay? And that's when you know, hey, I should probably do elimination on this, okay? Now, on the problem number 4, as you can see, we have x equals, okay? This right here is the single biggest indicator that we should use substitution. So we go ahead and plug that in, and that's going to be 3 on the outside of 2y plus 5 plus y equals 1. So what I did was I packaged this part up and I plugged it right in for x. Now I take this 3, I'm going to distribute it across, and that's going to be 6y plus 15 plus y equals 1. So that's going to be 7y equals negative 14, and all I did was I subtracted that 15 from both sides, and I divide each side by 7. I got y equals negative 2. So I know that y is going to be negative 2. Now I'm going to take that y that I just came up with, and I'm going to plug it back into the top. Okay, so we're going to package that up, and we're going to throw it right back into there. And that means that we're going to have x equals 2 times negative 2 plus 5. Now we got x equals negative 4 plus 5, and x equals 1. Alright? Now, easiest thing to do is just go ahead and run a quick check on this, okay? So we're going to take our numbers and plug them back in. This is an x value right here. This is a y value. So we go ahead and place those back into the original equation. So we plug the y into that first one. That's going to be 2 times negative 2. That's negative 4. Negative 4 plus 5 is 1. Okay? X is 1. We win. We did it right. Okay? Now we go ahead and we try that second equation. That's going to be 3 times 1. Okay, that's 3. And then plus negative 2. Okay? 3 plus negative 2 is 1. So there we go. We have 1, and that is a good, solid answer there. Now, number 5. What we're going to do with this one is, this is a substitution. Okay? Because if you think about it, we do have a y equals there. Now, we've got a multiplication there by 2. And that's easy to take care of, okay? So what we're going to do is we're going to go ahead and we're going to divide this side by 2 and that side by 2. And what we're left with is y equals negative 4x minus 12. And now we have something that is very easy to plug in. So we take this y right here, we're going to plug it right there. And what we're left with is 2x plus 5. And then we're going to take our y, what we came up to be y, and we're going to plug that in. So negative 4x minus 12. And that equals negative 6. Okay, now, the thing that I've seen a lot with at least my students' homework is that they have a little trouble with distribution, so don't forget to do that, okay? So we're going to take our 5, distribute it across, and we've got 2x minus 20x minus 60 equals negative 6. So now what we're going to do is we're going to go ahead and combine our like terms and add 60 to both sides, okay? So we're going to add 60 here and combine those, okay? And when we combine those, we're going to have negative 18x equals 54, okay? We divide each side by negative 18, okay? And when we do that, we wind up with x equals negative 3, okay? So we've got x equaling negative 3. Now what we got to do is we got to take this x equals negative 3 and plug it back into the beginning of our equation. Now, we don't have to go all the way back. What we can actually do is take this, since this part right here is the same as this right here, we can actually plug that negative 3 in right here and pop out our y like that, okay? And that's what we're going to do, okay? So we're going to take our negative 3, we're going to package it up, and we're going to plug it back in right here, okay? So we got negative 3 right here, and it's going to go right there, okay? So we got y equals negative 4 times negative 3 minus 12, okay? So we got y equals positive 12 now, because we did negative 4 times negative 3, negative times negative, positive. We minus 12 from both sides, and y equals 0. So we go ahead and plop our 0 there. Now, check. Quick run, okay? 2 times negative 3 is negative 6. 0 times 5 is 0. Negative 6 plus 0 is negative 6. Boom, that is checked, okay? And these checks are just that fast, okay? You want to be able to run through them like that, okay? 2 times 0 is 0. Equals negative 8 times x, which is negative 3. So negative 8 times negative 3 is positive 24. Positive 24 minus 24, boom, that's 0. Problem finished. And checked, okay? Now, we need to move down to here. Okay, I need to clear off some space. There we go. There it is. Okay, so moving along here, we've got 3x plus y equals 10, and y equals negative 3x plus 4. Now, the best method of approach here, since we have this y equals, we're going to use substitution. So we go ahead and plug in right there. It is just that simple of a substitution. So we're going to go 3x, okay, and we're going to package this part up, and we're going to put it right in there. So that's going to be negative 3x plus 4. I almost forgot to put my plus sign in front of that y, what y equals, okay, equals 10. So we got 3x minus 3x plus 4 equals 10. Now these 3x's, whenever we get our equation sorted out here a little bit, okay, we're going to have 3x minus 3x. That goes away. That's gone for. So we got 4 equals 10. Now, every last one of y'all should realize that 4 does not equal 10. Those are not the same number. So that's not true. When that is not true, we wind up with no solution. Okay? Now, no solution is the best solution for this case. Okay? So, there we go. Number 7. Okay? Now, number 7, there are actually 2 ways. I'll show you all how to do this on the director's cut, but for this case, I'm going to go ahead and I'm going to use elimination on this one, okay? We are going to multiply this bottom one by negative 1, so that's going to give me negative 3x plus y equals negative 4, and I've got negative 2x plus, whoopsie, minus y equals negative 16. Okay, all I did was I took that negative 1 and I distributed it all the way across. And keep in mind, I realized that I have that y there on top. I had this y right here. I needed something that's going to cancel. So I take this, so I just came up with negative 1. I know that if I multiply this y right here by negative 1, I'll get a cancellation like that, no problem. So, speaking of cancellation, I can go ahead and cross those off. I know those are gone now. And I have negative 5x equals negative 20. And I'm going to divide each side by negative 5. And when I do that, I wind up with x equals 4. Okay? Now, I can take this 4 that I have and plug it back into the top. Okay? And plugging that back into the top is going to give me something that I can work with. Okay? I take this x and I go ahead and plug it right there. Okay? We're going to go 2 times 4. Okay? That 4, I want to go ahead and do that in blue since, there we go. Okay, because that is the color that we came up with that answer in. So we got plus y equals 16. Now I have 8 plus y equals 16. I minus 8 from both sides, and I got y equals 8. Okay, so y is 8. Here, I'm going to make that look a little bit better. We're going to beautify that. Y. There we go. Okay, so y equals 8, x equals 4. Now, let's just go ahead and double check this just to make sure that I did this right. Now, we got negative 3 times 4, that's negative 12. Negative 12 plus 8 is negative 4. Okay, did that part right. Now, I've got 2 times 4, that's 8. 8 plus 8 is 16. At least I hope it is. Alright, so, number 8. Okay, so I see just elimination. I see that negative 3x and I see that positive 3x. The first thing that screams at me is, hey, I'm elimination. Okay, so we're going to go ahead and we're going to add these two rows together. And I'm going to go, bloop, and I'm going to cancel those out instantaneously. And I go ahead and I look at the rest of my problem and I go, uh-oh, those aren't the only thing that eliminated. I've got 2 and minus 2y, so those cancel. And then I've got 9 and negative 9 canceling. Oh my goodness. Okay, so what we have is we've got 0 equals 0. Now, that is a true statement. At least I hope 0 equals 0, or math is going to dissolve all over the place and everything that I've done is for nothing. So, what we say whenever 0 equals 0 is that there's infinitely many solutions. Okay? Everything is an answer. It doesn't matter what you plug into the top, you'll get the same thing. You will get 9. And then whatever you plug into the bottom, you will always get negative 9. It always works, and it's great. Okay? So, what we say for the solution here is, we can say all real numbers. We can say infinitely many answers, or we can say infinite solutions. Whatever you like. It depends on what your teacher likes. Okay? Okay, so moving along here. We've got 2x plus 3y equals 11 and negative 4x plus 6y equals 14. Now, here's the thing. I see that my x's line up here. I see that my y's are lined up here. I see that my equal signs are lined up here. I see that even my constants are lined up here. Okay? So, what that just screams to me is that this is going to be an elimination problem. Now, when I use elimination, though, nothing actually says 0 pair right up front. So what do we have to do? We have to come up with our own 0 pair. So how we do that is we multiply this top row by 2. And when we do that, we wind up with 4x plus 6y equals 22. Okay, now we don't have to touch the bottom row because the bottom row has that negative 4x, which is going to cancel nicely with the 4x that we just came up with. So we got negative 4x plus 6y equals 14. Okay, now this is something that we can work with. Okay, we can see that these 4x's cancel, and what we're left with is 12y equals 36. We divide each side by 12, and we're left with y equals 3. Okay? Now, I know that I'm writing it below it. Get over it. So, we got y equals 3. We take it, and we plug it back in right there. So, it's going to be, we're going to go 2x plus 3 times 3 equals 11. Okay, now I'm left with 2x plus 9 equals 11. I subtract 9 from both sides. 2x equals 2. We divide each side by 2, and x equals 1. Alright, so we take this 1 that we just came up with, and a quick check. We're going to go 2 times 1, that's 2. 3 times 3 is 9. 2 plus 9 is 11. Yes, checked. Okay, now we're going to go through and do a quick check on that second equation, make sure that it works. So we're going to go negative 4 times 1, which is negative 4. 6 times 3 is 18. Negative 4 plus 18 is, in fact, 14, and we did that problem correctly as well. Alright, moving right along. Okay, so, number 10. We've got 5x minus 3y equals negative 4, and we got x plus y equals negative 4. Now, what I see is we can multiply this bottom row by either negative 5 or positive 3. We could also subtract x from both sides on this bottom equation right here and wind up with y equals negative 4 minus x, plug that in, and we have a substitution problem. It all depends on how you feel the most comfortable. If you like substitution, minus x. If you want to do some elimination, it's up to you. Now, I'm going to do elimination on this, okay? So, we can go ahead and we can multiply this one by 3. Okay, I like working with positive numbers. That's how I roll, whatever. So, we got 5x minus 3y equals negative 4. We multiply this bottom one by 3x. Okay, or 3 rather, my fault. Okay, 3, and we're going to do 3x plus 3y equals negative 12. Now, we can see that this is going to cancel very easily, and it makes it to where we have something nice to work with on the end here. We've got 8x equals negative 4 plus negative 12. Check it with your calculator. If all else fails, use your calculator. Negative 4 plus negative 12 is going to be negative 16. Don't lose your signs. It will destroy your grade. Divide by 8. Divide by 8. X winds up equaling negative 2. Okay? And I'm sorry that my handwriting's getting a little big here. So negative 2 is our x. So we go ahead and we take our negative 2 and we're going to plug it back into our one of our original equations, okay? I'm going to use this one right here. So I'm going to go negative 2 plus y equals negative 4, okay? Now, that negative 2 that I had down here is right here now, okay? So I can use this to solve this problem. So I can add 2 to both sides here, and now I have y equals negative 2, okay? Now, quick check, okay? Negative 2 times 5, negative 10. Negative 2 times negative 3 is positive 6. Negative 10 plus 6 is negative 4. Yes, did that right. Negative 2 plus negative 2 is negative 4. At least I hope it is, or we're in big trouble. Okay, so this last problem, I see y equals. This right here is the single biggest indicator that, hey, you should probably use some substitution. Okay, so we go ahead and we take that, plug it in right there, okay? I'm going to do this part in blue. So we got x minus, okay, 2 plus x equals 4. All right, Now, we got x. Now, don't forget this right here, this negative, this minus is actually almost like saying that we're minusing 1, and that minus 1 is going to distribute across to both of those. Okay, so we're going to have x minus 2 minus x equals 4. Okay, now I see this part right here. Okay, now keep in mind the sign in front goes with that symbol, so that is x minus x, which says that's going to be a 0. So what I'm left with is negative 2 equals 4. Okay, negative 2 equals 4. Last time I checked, that's a no-no. That does not happen. So the best solution is that there is no solution. Okay, so there we have it for that part of this review. Next part. Alright, so it says for problems 12 and 13, write a system of linear equations and solve using any method. Don't forget to define the variables. Okay, now, due to the fact that I always forget to do this, I try to underline it just to remember. So, it says, number 12, it says the sum of two numbers is 80. Their difference is 38. Okay, find the numbers. Now, we're going to go ahead and say x is number 1, and y is number 2. Okay, those are not hashtags. That is the pound sign, and it represents the word number. Okay, so we are going to go ahead and solve this. Okay, it says the sum. Now, when I see sum, my brain instantly throws up a plus sign in my head, and that's a really ugly looking plus sign. I'm going to fix that. Alright, now it says their difference is 38. And when I see difference, my brain instantly just goes pop. Now I see a minus sign. Okay? Now, it says the sum of these two numbers is 80. So I say x plus y equals 80. And then it says that their difference is 38. So I go x minus y equals 38. Now, when I look at this problem, I go, what sounds good? I think elimination, okay? When I see that plus y and that minus y, that just screams, and I want to go away. Okay? So, we got 2x equals 11, 8. Okay? Now, I divide each side by 2, and I've got x equals, that's going to be 59. Alright? So, I've got x equals 59. Okay, I can take that 59 that I just came up with, and I can plug it back in right in there. Okay? Now, 59, here, we're going to write that in blue. So we're going to have 59, okay, minus y equals 38. Okay, now I subtract 59 from both sides, okay, and negative y equals, okay, and when I do 38 minus 59, God, bro. 38 minus 59 is negative 21. Okay, so I got negative 21 there. I divide by negative 1 on both sides to make that a positive y. I have y equals 21. Alright, now, x equals 59. And 21 is our other number. So, just to double check, we do 59 plus 21. Does 59 plus 21 equal 80? Yes, it does, okay? And now I need to make sure that 59 minus 21 actually equals 38. So we can go ahead and we can use our calculators. That is just fine. Do it. It's useful. Okay, 59 minus 21, just as we said, is in fact 38, and therefore this problem is officially verified, and we know that it's right. We know that you can turn this in and get that problem right. Okay, the perimeter of a rectangle is 36. Okay, here's the big thing. Okay, always draw a shape. If it says the perimeter of a rectangle, we go ahead and we draw ourselves a rectangle. There's nothing wrong with it. Okay, I've been doing that since the 3rd grade. It's fine. Do it. The length is 3 less than 2 times the width. Okay, so we're going to go 2 times the width, and it's 3 less than that. Okay, so we're going to subtract 3 from it. So 2 times the width minus 3. That is 3 less than 2 times the width. Alright, so the width is right here. Now, name the variables, okay? So, our variables, if you haven't already guessed, are going to be L, which is going to be the length, and the width, which is W. We already those are just common, so that's what we're going to use. Now, the perimeter, okay? There's several ways that we can do this, okay? I'm going to do the short addition, okay? So we're going to go 2W plus 2L, okay? Equals the perimeter, which is 36, okay? Okay? So we know that 36 is the perimeter. It says it right there. 2W plus 2L equals P. That's something that you should remember from elementary school. Please, I hope that you do. Alright, so we've got 2W plus 2 times 2W minus 3 equals 36. Now, this right here is our substitution, okay? We know that this is the length, okay? I just replaced this L with that L. It's no big deal. It's all good. We know that L is 2W minus 3. So, let's go ahead and do some distribution here, okay? I'm going to take this 2 and go with that. So that's going to give me 2W plus 4W minus 6 equals 36. So that's going to give us 6W minus 6 equals 36. We add 6 to both sides, and that's 6W equals 42. Divide each side by 6. And we have W. Ooh. And we have W equaling 7, okay? Now, 7 is the width. So, what we can do is we can go ahead and we can plug that 7 back into the beginning, and we're going to have 2 times 7 minus 3 equals L. Okay, so that's 14 minus 3 equals L. Okay, and that's 11 equals L. Okay, now, what we want to double check is, does this actually equal 36 when we add it up? So, 11 times 2 is going to be 22. Okay, 7 times 2 is 14. So we got 22, and we got 14. Okay, that's 36. Okay, that's supposed to be the perimeter. It's right there. Okay, that means that we did this problem right and that we're good. Okay, now let's go ahead and move this along. Okay, it says to find the solution to the system of equations represented by this table. Now, let's see. These tables. Tables are easy, for the most part. If you can just notice that you have 2 of the same point, you're set, okay? Now, that is purely being able to read a chart. If you can see, you can get that question right, okay? And I hope everybody gets that right, or Mr. Houston's going to cry, and it's going to be sad, okay? So, moving along to number 15, okay? Now, this one's a little more tricky, okay? Because if you look, we've got negative 1x, or negative 1, 6, 1, 4, 3, 2, 5, 0. Okay, we got negative 2, negative 5, 0, negative 4, 2, negative 3, and 4, negative 2. There's no clearly defined, boom, that's the answer, okay? We have to actually work at it on this one, okay? So, between here and here, we got plus 2. Between here and here, we have minus 2. Alright, so, that's going to be, let's see. That gives us y equals negative x. Okay, now we have to find our intercept. Okay, so 3 times negative 1 is going to be negative 3. Negative 3 to 2 is going to be plus 5. Alright, so there's one equation. Okay, next equation, we got to go over here, and we got to go 0 to 2, that's going to be plus 2. Negative 4 to negative 3, that's plus 1. Okay, or plus 1, I mean. Plus 2 from 0 to 2, plus 1 from negative 4 to negative 3. Okay, so that's going to give me y equals change in y over change in x. That's going to be 1 half x. Okay, 4 times 1 half is going to be 2. 2 to negative 2 is going to be minus 4. Okay, so there's our second equation. Alright, so what we can do is we can go ahead and I'm going to do some substitution on this one. So I'm going to say negative x plus 5 equals 1 half x minus 4. I'm going to go ahead and subtract 5 from both sides. Okay. Ooh. Alright, so that gives me negative x equals 1 half minus 9. I'm going to go ahead and subtract 1 half x from both sides. And that's going to give me negative 3 halves x. And that equals negative 9. I'm going to multiply both sides by 2 over negative 3 to get rid of this. Okay, so I multiply both sides by negative 2 over 3. And that's going to give me 18 over 3, which is going to be x equals 6. Okay, now, as you can see, neither one, that does not show up in either chart, and that's okay. Now, what I can do is I can take this 6 and plug it into one of these two equations and come up with what I need, okay? So I've got, let's go with y equals negative 6 plus 5, y equals negative 1. Alright, now, if I plug those in, if I plug in these two numbers into these two equations, what I should wind up with is a good solid answer. So negative 6 plus 5, that is negative 1. That's good. 6, that's going to be into this one. That's going to be 1 half. Okay. 1 half minus 4, or 6 times 1 half is 3. 3 minus 4 is negative 1, which is what we started out with, which is good. And that means our final solution is going to be 6, negative 1. Okay, and there we go. Alright, so now we are on to the multiple choice section of this. Okay, choose the correct system of equations that would solve this problem. Now, there are 22 students on a bus. Okay, there are 14 more girls than boys. Okay, so here's the thing. Whenever I read this problem, I see 22 students on a bus. My brain instantly goes, what kind of students, okay? And then I see this part right here, and this screams to me, 14 more girls than boys. That says girls and boys, okay? That's where my brain goes. And then further on in the question, it says how many of each on the bus. And then when it's referring to each, it means girls and boys. Okay? So that all stands out in my head whenever I read that problem. That all flashed through my brain, boom, like that. Okay, so we've got G plus B, which is going to equal 22. Okay, we know that because of this right here. There are 22 students on this bus. Okay, now we've got 14 more girls than boys. Okay, so what we have to do is we have to go ahead and we have to write out, okay, boys plus 14 is going to equal the number of girls. Now, it doesn't have to be that the G is on the right of that sign. We can flip it around and have the G on the left and have G equals B plus 14. So G plus B equals 22. That means that we can go ahead and get rid of this and this because of those minus signs. Those answer choices go away. I've got G plus B equals 22 here and here, and that's okay. Now, let's look at our other answer choices. Okay, it says G equals B plus 14, G plus 14. We're supposed to have B plus 14. This is wrong. That goes away. We're left with A. Alright, now, number 17. Tickets for a game were $5 for adults, $2.50 for children. And 373 tickets were sold. Okay, so let's back it up for just a second. I have adult tickets. I have children tickets. Okay, and then 373. So I go A plus C equals 373. My brain, boom, does that. And it's just that fast. Now, next thing that my brain says is $5 for adults, $2.50 for children. Okay, and then it says this is money, this is money, there's money. So I've got 5A plus 250C equals 1232.50. Okay, now let's see what we can eliminate based off of what we came up with. We got A plus C equals 373. This is good. This is good. This is bad. That's not good. This right here, not good. That goes away. Okay, now let's see what else we can do. We got 5. Ooh, 5 is going with the C. That doesn't work. Okay, now we got 5A plus 250C equals 1232. Hey, that's what we just did. So that works. That's a good one. Okay, next problem. We've got speedy delivery services. Okay, they're delivers its standard crates using a fleet of vans and trucks. A van can hold up to 20 standard crates, and a truck can hold up to 35 standard crates. If Speedy Delivery Services needs to deliver exactly 270 standard crates at one time using 12 full vehicles, which system of linear equations could be used to determine the number of vans, X, and the number of trucks, Y, for delivery? Okay, so we've got X equaling truck or vans. We've got Y equaling trucks. Okay, we have to make sure that we keep this straight. Okay, so X plus Y, regardless, needs to equal 12. It's because we're looking for 12 full vehicles. So we got Y plus X equals 12. We know that part. That part's good. Now, what goes with the number, what is going to go with the vans? What do y'all think? Or with the trucks even? Okay, what's going to go with the trucks? We need 35 going with the trucks. So it's going to be 35 Y. Plus, what number goes with the vans? Let's see. It says a van can hold up to 20 standard crates. So we need to go 20X. Okay, and that's going to equal how many crates do we need to carry again? It says it right here, 270 crates. Okay, so we go 270. So we got X plus Y equals 12. That goes away because of that. This goes away because of that. So that doesn't work for us. X plus Y equals 12. Good and good. 35 needs to go with Y. Oops, they messed up there. Doesn't work. 35 with Y, good. 20 with X, that's good. This is a good answer. Okay, Moving right along, River collects old coins. He collects only nickels and quarters. Okay? Kind of a weird taste in coinage, but whatever. He collects only nickels, okay? My brain says 0.5 in. My brain also says 0.25 Q. Okay? When I hear nickels, I hear 0.05 in, and I hear 0.25 for quarters. That's just how my brain works. Now, his 29 coins consist entirely of nickels and quarters, so we know it's going to be N plus Q equaling 29. Okay? So, N plus Q equals 29. What can we get rid of? This goes away because of that N minus Q. Everything else, what about this? 365, that can go away. So we've got N plus Q equal 29, N plus Q equals 29. Those are good. So, what else can we get? Okay, it says the value of the coins in his collection is 365. So, if you notice right here it says 25Q and 5N. If you notice down here I said 0.05N and 0.25Q, okay? That is the monetary value of a nickel and a quarter, okay? That says that quarters are worth $25 and that nickels are worth $5. No, that doesn't work. So B is our correct answer. Alright, last page. So, these are just multiple choice questions. They should be pretty quick, pretty easy. Okay, so we'll start off with number 20. Terry made the table below for the system of equations 2x plus 1 and y equals negative 3x plus 11. Now, you can go ahead and plug those into your calculator, see what they look like, but we don't really have to. Now, if we look at number 20 in depth, okay, doesn't take much really, okay. A lot of depth there, right? 2, and then you can see that this and this are the same thing, okay? When those are the same, that means that you have found the solution, okay? Now, they have to be on the same row. If they are not on the same row, okay, it doesn't work. Now, 2, 5, and 5. Boom. It is just that easy. That means that the solution is 2, 5. B. Done. Okay, real in depth, real difficult there, y'all. Alright, now, number 21. If the system of linear equations is x plus 2y equals 2, and y equals negative 1/2 x plus 1 are graphed on the same coordinate grid, which of the following is the solution to the system of linear equations? Now, there's a couple of different ways to do this. From standard form, the easiest way to do it is actually calculate the intercepts. Now, if you remember, there's this really nifty little blackout trick that we taught y'all, okay? Now, the blackout trick, if we cover up the y term, okay? Covering up the y term, we can look and say, okay, that's a 1 in front of the x. We divide the x by the x term by 1 and divide this by 1, and that means that the x-intercept is 2. The y-intercept for that equation is 1. Okay, y-intercept is 1, x-intercept is 2. Okay, now I know that this might be a little foreign to some of y'all, but that from here to here, that's down 1 over 2. Since it's a straight line, we have to continue that pattern. So we go down 1 over 2, down 1 over 2. And then we got that going up the other way, okay? So we got to go ahead and connect those dots just like that. And sorry, y'all, I don't have a straight edge with me that works on the computer. The line tool on this is horrible. So I apologize for my raunchy lines, okay? I really do apologize. Okay, now the other line says y equals negative 1/2 x plus 1. Now we already know how to deal with these. These are easy. So we start off at 1. Okay, and we're going to go down 1 over 2. So down 1 over 2, down 1 over 2, down 1 over 2. I'm kind of getting that there's going to be a pattern here. I don't know about y'all. Okay, so I go ahead and I connect those dots, and wow, it seems like that line is right on top of my other line. So what that means is that we got infinitely many solutions. Alright, when you have one line right on top of the other, that's how it works, okay? Alright, so now it says that we're going to solve this system of equations. Okay, so solving a system of equations like this is not too horrible, okay? So, what this problem is telling me, and no, I'm not going crazy, these problems don't actually talk to me, but this problem, whenever it has the x's above the x's, the y's above the y's, the equal above the equal, the number above the number, okay? What this problem says is that we're going to do some elimination. Now, the easiest thing for me to do would be to multiply this top row by -3 and multiply this bottom row by 4. And what this is going to do is it's going to give me an x term that will cancel. Okay, it will give me a nice zero pair out of the x's. So I'm going to have -12x minus 15y equals -24. Okay, now I've got 12x minus 8y equals -68. Okay, now, just like I said, these x's are going to cancel, and I'm going to be left with -23y, which equals -92. I divide both sides by -23, and that gives me y equals 4. Okay, now, there's only one answer choice out of this whole problem that has y equals 4, and that's going to be C. Now, if that did not pop up, what we could do is we could plug this y back in the top and solve for x, which I will go more in depth with in the Peter Jackson extended edition. Okay? The tables correspond to two lines in the coordinate plane. What is the y coordinate at the point of intersection? Okay, now this one just so difficult. I don't know if y'all can do it. 412. 412. Y coordinate. Y. Ooh, that's so hard. Toughest problem ever. Y coordinate is 12. And it's done. Okay? Alright, now, I hope that y'all enjoyed the review. Okay, good luck on your test.